Welcome to the next part of Mosfet problem solving lecture series. So in our today class we are going to learn something new. If you observe the given question, the value of given data is IDSS equal to 10 milliampere given, and the value of VP equal to minus 8 voltage, and they have given one diagram, and then we are requested to calculate the value of ID and VDS. Okay, sir, how to solve this question? And if you observe the question carefully, they have given one more data. What is the data, sir? VP equal to minus 8. If you observe in our previous problems at all, I was talking about only VT. VT means threshold voltage. Then what is this VP, sir? When this VP is given and IDS is given, what is the actual meaning of this? Let me tell you. Basically, the value of VP stands for pinch of voltage. VP, it indicates pinch of voltage. Okay, sir. So when this pinch of voltage will occur? This will occur when we are taking the MOSFET, when your transistor is entering into saturation region, that starting point of saturation region, whatever the voltage that you are observing in the x-axis, that is simply called pinch of voltage. I hope you all understood what I am trying to conclude here. So if you observe the drain to source voltage, let me draw the characteristics. So here what I am going to do is, let us take VDS, drain to source voltage, and let us draw the curve between drain current and drain to source voltage. Here what will be happening is, when transistor is in linear region, then the curve between VDS versus ID, it will be linear almost. It will be linear. Okay, sir. After that what will happen? Once your transistor reaches its pinch off point, it means it is entered into saturation region, current will become constant. Now if you observe, before this saturation region, the relation between ID and VDS are almost linear. Linear means the value of resistance is constant. How it is constant? According to Ohm's law, R is equal to V by I, that is VDS by ID. You can use capital also, I kept a small here. So it should be, it should be VDS by ID. But since both are linearly varying, it means if voltage is reaching 2 voltage, current will reach 2 ampere. 2 will get cancelled, remaining you will be getting 1 only. If voltage reaching 4 voltage, current will be reaching 4 ampere. 4 will get cancelled, again you will be getting 1. So the relation between ID and VDS will be linear when you are in linear region. But once it is reaches this pinch off point, once it is reaching its pinch off point, so this point is called pinch off point, and its correspondent voltage is simply called pinch off voltage. Yes, it means after that transistor is entered into saturation region. Okay, sir. So directly you can take, whenever pinch off voltage and saturation currents are given, you can directly treat the transistor entered into saturation region, its correspondent current, that is called drain to source saturation current, or maximum current that is flowing from drain to source. We can also define like that. Okay, sir. Now here I will be bringing one more formula. This drain to source saturation current can also be written, right? How can we calculate the value of drain to source saturation current, sir? It can also be calculated with the help of drain current ID upon 1 minus VGS upon pinch of voltage VP whole power 2. From here, suppose if you are requested to calculate the value of drain current, directly you can write drain current ID equal to drain to source saturation current, maximum current, into, you can write 1 minus gate to source voltage upon pinch of voltage VP whole power 2. Okay, don't forget, here this IDSS indicate the drain to source maximum saturation current. If you are simply requested to calculate the drain current, if you observe in our question, what is the value of drain current and drain to source voltage? You know, when our transistor is entering into saturation region, I have given one more formula to calculate the value of ID. Yes. What is the alternative formula? We are also having one more formula in the saturation region. ID equal to mu n Cox omega by 2L into, in bracket we have to consider VGS minus threshold voltage whole square. Yes sir, this is also correct. But in our question they haven't given any data. Is there any information about mu n Cox omega by L or threshold voltage? No. They have given data only about pinch off voltage. Whereas what is threshold voltage? Threshold voltage is the minimum amount of voltage that is required across the gate to source terminal to turn on the MOSFET. Yes or no? So there is a difference between pinch off voltage and threshold voltage. Pinch off voltage means it is the point where your transistor about to entering into saturation region. Whereas threshold voltage means it is the point where your MOSFET is about to enter into linear region. It is going to be turn on. So that is the difference between threshold and pinch off voltage. I hope you all understood what are the things that I have delivered. Okay sir, then in the threshold region, in the pinch off region, what is the relation between drain to source voltage, gate voltage and threshold voltage? So whenever they are asking you to write down the relation between VGS, VDS, VT in pinch off region. In pinch off region, what you have to write is, we are almost entering into saturation region. So what you have to write? Directly you can write the relation that VDS equal to VGS minus VT, because we have been entered into saturation region. Exactly at this point, these two people will become equal. Okay. I hope you all understood what is the conclusion, what are the things that I have delivered here. Okay. Now come back to the question. Okay sir. So from this, what is the conclusion? If you observe the question, they have given the value of a pinch off voltage IDSS and we are requested to calculate the value of ID and VD. As usual, whenever we are calculating the value of ID, VDS at all, we are doing DC analysis. It is same as our bipolar junction transistor BJT. In BJT, always we are trying to calculate the value of emitter current, collector to emitter voltage, resistance value. These kind of calculations we will be always doing in DC analysis. Whereas when we are entering into AC analysis, we will be calculating four terms. One is voltage gain, current gain, output impedance, input impedance. So that is called AC analysis. So in MOSFET, so far whatever the things that we have done, that is simply called DC analysis. Of course, still I am doing DC analysis only. In the upcoming lecture, after completing the whole DC analysis, now we are solving problems only related to DC analysis. Once it is fully completed, then we will be solving problems related to AC analysis. Okay. Now let us take the question. See, when we are doing DC analysis, if you observe in MOSFET, in MOSFET, they have given two capacitors. Yes or no? Yes sir. Here one capacitor is there, here one more capacitor is there. What will happen to these capacitors? Sir, these capacitors will get open circuited. Why? Because we are doing DC analysis. While doing the DC analysis, automatically whenever a capacitor is permanently connected with the DC supply, it will get open circuited. So I can say these capacitors will be open circuited, sir. Kindly forgive me some small disturbance. Okay sir. So these capacitors will get open circuited. So next what we are going to do now, it's time to solve the problem. Okay sir, if the capacitor will get open circuited, then how can we redraw the circuit? So it is your responsibility to do that. So just to take the circuit and redraw it. Okay, fine sir. So if the capacitors are open circuited, I am just redrawing the circuit. Just take very less time. It will be like this. Yes sir. Now tell me, what are all the parameters that are required in order to crack our question? The question is, what is the value of VDS, and also we have to calculate the value of ID. Okay sir. So this is going to be 2 mega ohm they told. Anyway, now let me ask you few questions and then we will be solving the question. Tell me, what is the amount of current that is always entering into gate terminal of the MOSFET? We know bipolar junction transistor is a voltage controlled device. So the current that is entering into the gate terminal is always 0 ampere. It means there will be no any current flow in the gated terminal. Then what is the voltage drop across this 2 mega ohm resistor? To the voltage drop across the 2 mega ohm resistor can be written as 0 ampere current into 2 mega ohm resistor. According to Ohm's law, V is equal to I into R. Since the value of I is 0, value of R is 2 mega ohm. 0 into 2 mega ohm will become 0 only. So there is no voltage drop across the resistor. It means you no need to consider that resistor. Directly you can short circuit that terminal. Now it is become useless. Okay, you don't need to consider that effect. Then this negative voltage, see there, negative plate is connected with the gate terminal. Okay sir, so that will be reflected across the gated terminal of the MOSFET. So from here, let us explore the value of Vg. Tell me what is the value of gate voltage? It is minus 2 voltage now. Sir, why it is minus 2? Because the polarity of the source, if you observe, gated terminal is negative, opposite, negative plate is connected with the MOSFET. So that is minus 2 voltage. Next, what is the value of source voltage? If you observe, this is source terminal, this is drain. Sir, source is directly connected with the ground. So ground potential is 0. We know source voltage will become 0 now. From this I can say gate to source voltage VGS can be written as Vg minus Vs. So what is the value of Vg? Vg is minus 2 voltage, minus of Vs is 0. So I can simply say the value of VGS is going to be minus 2 voltage. Okay sir, we found the value of gate to source voltage. We also know the value of pinch off voltage, that is already given as minus 2 voltage. Okay, fine sir. So everything is given. Sorry, what is the value of pinch off voltage? It is minus 8. Change this. 1 minute. Yeah. So this is minus 8 voltage. Now we know the value of gate to source voltage, pinch off voltage. What we can do is directly by using this formula we can calculate the value of ID. That is first step what we are going to do now. Let me take that formula. The value of drain current ID can be written as drain to source saturation current or maximum current into 1 minus gate to source voltage upon pinch off voltage Vp whole square. So from here we know it is given as 10 milliampere, 10 into 10 power minus 3 into 1 minus, what is the value of VGS? Minus 2, Vp minus 8. So here this is minus 2 upon, this is minus 8 whole power 2. From here I can say it will be 10 into 10 power minus 3. In bracket it will be 1 minus, see minus minus will get cancelled. 2 by 8 can be written as 1 by 4 whole square. Further, if we reduce this expression, it will become, I am just taking LCM, 4 minus 1 will become 3, 3 by 4. So this can be further written as 10 into root 3 by 2. Yes or no? I can take 4 outside. So root 3 we can't directly take it outside. But what is the value of root 3? Let us see. That is 1.732. So it will be 10 into 1.732 by 2 into 10 power minus 3. What is the finalized answer? From here, sir, it will be 17.32. Yes. So it will be 17.32 into 10 power minus 3 by 2. Yes or no? I hope you all understood what I am trying to conclude from here. Right? 1 minute. Yeah. 4 minus 1, 3. It is root 3. Sorry. My mind is doing the same mistake every time. See there. We are squaring. We are not taking square root, right? 4 minus 1, 3. 3 square will become 9. 4 square will be 16. So it will be 9 upon 16. Sorry, forgive me. Just to do the calculation now. It will become 19 by 60. Directly we can solve. 19 by 16 means it will be equal to 5.625 10 power minus 3, that is as usual milliampere. That is the value of drain current. Okay sir, one calculation is done. Go back to the circuit. What is the another value? VDS equal to dash. If you observe, the drain current is going from here, that is the drain current. Current entering point plus leaving point is minus. Then the voltage that we are observing between drain to source, that is called VDS. Okay sir, here this 20 voltage can be marked. This is plus 20. It means positive plate is connected with the circuit, negative plate is connected with the ground. So this can be written as minus plus 20 voltage. Okay sir. Now if you apply KVL for this loop, what you will be getting? This will become minus 20 voltage plus voltage drop across the resistor ID into, that is 2 kilo ohm, right? So 2 into 10 power 3 plus VDS equal to 0, that is the KVL. Yes or no? See there, starting polarity is minus for the source, starting polarity is plus for the resistor, starting polarity is plus for the VDS terminal, equal to 0. Now you know the value of ID, just now we have been explored, that is 5.625 milli means 10 power minus 3. Now already we have 10 power plus 3, 10 power minus 3, it will become 1. Then again we have to multiply it by 2, then you have to subtract it by minus 20. See, I am doing directly. If I am doing that, the value of VDS coming, yes, 8.75 voltage. That is the value of VDS that I am getting here. I hope you all understood. So in this lecture I have taken a little bit time. Anyway, I have delivered whatever the things that are required. So don't forget anything, whatever the things that I have delivered here, just to make a hint. This is all for this lecture. Remaining things we will see in the next class. Thank you all.